Welcome. This is a video on nanoflotation treating cooling water at a refinery. The first part of this video will focus in on the flotation component of nanoflotation. Flotation is undertaken using a froth generation system or dissolved air flotation. Our preference is froth generation because of the smaller footprint and the very low energy requirements. This is a sample of the water that is going into the flotation cell. This would be the raw cooling water, and it is about 150 NTU as far as turbidity. This particular plant also has the ability to operate with nitrogen in environments where there is high H2S. In this particular case, we were not using nitrogen. We were using a froth air flotation system. That's the flotation cell. And you can see it has a cover on it, and there are two access hatches. This is the actual froth itself, and you can see the skimmer comes across the beach and drops the skim layer into a skim trough, and then you can see the overflow of the treated water that will be going to the replaceable skin layer membranes, and that is a key component of the nanoflotation technology. This is the control panel, and we are now scanning up to the actual membrane bundle. Inside that acrylic housing, there are a number of stainless steel tubes. Those tubes are a membrane that does not have a fixed skin layer, membrane skin layer. Typical membranes have an affixed skin layer. This, by the way, is a sample of the water coming out of the flotation cell and will be going into the replaceable skin layer membranes. These membranes, they do not have a skin layer on them, and we put a skin layer on them by adding a powder before the filtration run, very thin layer, and then that layer acts as the skin layer. It allows us to increase our flux rates dramatically on the membranes, 10 to 15 times. It also lets us operate at very, very low pressure, below 1 bar. In fact, at 1 bar, we won't go any higher than 1 bar. This is, by the way, a sample of the water after the membrane, and the turbidity of the water going into the membrane was about 4 NTU, and coming out of the membranes was less than 0.2 NTU, 0.2 NTU. But the membranes themselves, these are the tubes, and as I said, we add a powder to that tube that creates the skin layer. It improves the flux rate dramatically and reduces the pressure requirements dramatically. We do not operate over 1 bar. At 1 bar, we will backwash off the membrane skin layer. It takes about 1 minute, 1 to 2 minutes, and then we would put a new skin layer on, which takes another 2 minutes. These are samples of the water. So on the left is the water, raw water going in. The center is the flotation water coming out of the flotation cell, and then the water coming out of the membrane bundle. I said about 150 NTU, 4 NTU, and less than 0.2 NTU. Now you can see that the water here, it is running on a continuous basis, and that water is now being discharged back into the refinery's cooling water return system. This gives you a view of the pilot plant, and it is obviously mobile. We can take it to any site, operate it, and demonstrate the capability of the technology on different waste streams. There are 2 outlets that take the wastewater out of the pilot plant. One is on the top and the bottom of the membrane, and then we have a third water connection, which is the clean water coming back into the pilot plant. We use clean water, or the treated water, for any water required for the slurry to add the replaceable skin layer and for froth generation. This is the skim layer tank. So we're dumping the skim layer from the froth flotation into this tank. You can see it there. So thank you for watching. If you are interested in having the pilot plant to your site, please give us a call at 1-604-922-0137.